All right. So today we're going to be going over JavaScript objects as our next data type. We previously went through numbers. We previously went through functions. We previously went through variables. So those are what we've touched so far: variables, functions, if-else statements also as well, if-else statements, into ternary statements, and then conditionals. Ran through conditionals, ran through switch statements. But the last one we went through was numbers. So real quick, let's just review what we went through with numbers, right? The two type of numbers we can have are generally ints and floats. What's the difference between an int and a float? I'm just gonna call on somebody randomly. We're actually gonna go through the list every time to the names. Arnelia, what's the difference between an int and a float?
An int is integers, so there are numbers, and a float is decimal numbers.
Correct. Whole numbers. Integers are whole numbers, no decimals. So yeah, correct. And they are treated as different data. Are they treated as different data types? Let's see. Type of int equals type of float. They should be both treated as numbers. And I believe when we did this, we got both of the same types. Type of float, which was a number. Number methods. John, I guess you weren't part of this class, but let's see. Do you understand what number methods are?
If I recall correctly, they let you display values like say what you have online, 102.
Yeah.
Yeah, because those are not objects, so you have to you have to display them using the numbers method.
All right. So one thing, everything in JavaScript is an object.
Mm-hmm.
Hence why we have the ability to use a method on a number. So what's really happening here, right? Lots of decimal is really something that's like new number, and then pass in the value, whether the value be a string or an actual number or whatever the hell. It creates a new number class. And on this new number class is a whole bunch of functions that exist specifically on the class number. Any function that exists specifically on a class is called a method. A method is a function on a class. That's literally all it is. Nothing special. So if you understand what a function is, there are specific functions that exist on certain classes. On the number class, we have functions like to fix. As you were mentioning, like there are methods that allows you to manipulate numbers. So one of them is to fix, number.toFix, number.toString, and a whole bunch of other ones. So I can comment this out. And you'll see lots of decimal is a number. And we're calling the method to fix from the number class. Right? Does that make sense? Does it make sense that to fix is a method that exists on the number class?
So it's only can be called underneath the lots of decimal, you mean?
Lots of decimal represents a number class. Lots of decimal is a variable, right?
Oh.
The variable is containing, we are assigning a new number. And when I say new number, a new member of the number class with this value attached to it. So when this new number gets created, number constructor, an object that represents a number of any kind. All JavaScript numbers are 64-bit floating point numbers. Not super important to know what that means. Just understand that they are numbers with decimals that takes up to a certain amount of information. But yeah, this is a new number, and on this number class exists a certain amount of methods. So if I change this name to number, the variable is called number. It points to a number data type. Number, it points to a number data type. And on this number are a certain amount of methods I can call. I can call toFix. Oops. I can call toExponential. I can call toLocalString. I can call toPrecisions. I can call toString. These are all the functions that exist on the number class. Any number will have access to these methods because as long as it's a number, I can say lots of I can turn this back to lots of decimal. Another number equals 1. And now I can say another number and also call toFixed on it. Or I can call toFix, toPrecision, toString, and turn this to a string. And just like any other function, I invoke it with parentheses. Parentheses allows me to call the function, and this function will give me back something. So let me show you what that looks like in Google Chrome. We're going to open up our console. So if you open up your Chrome, you press inspect. Let me know if y'all on your Chromes and y'all press inspect. And then open your console. It's under the console tab. From here, you want to assign a number to a variable called num. And since you're in your console, you don't have to declare the variable. You can just say the name of the variable. So we're going to say num equals 1. And then we're going to see what methods exist on num. These are all methods. These are all methods on the number class. Number to string will give us the number 1 as a string. And then I can say another num. And this time I can make it a float. And this num is also going to have toString because all numbers will have access to number methods. Does that make sense? Arnelia, does that make sense?
Can you repeat that again? Sorry.
John, does that make sense?
A little bit.
BJ, does that make sense?
I'm not.
A little bit.
All right, what do y'all understand? I want y'all to explain it. And then from there, I'm gonna see if I can fill in the gap from what y'all understand.
You said a number has access to a number string.
No, a number has access to the methods available to numbers. So the first question is, what is a method? Do y'all understand what a method is?
It's an object.
No.
Method.
John, what's a method?
A method pertaining to JavaScript is
I just said it.
is actions that can be performed on objects.
Yes, but no. It is a function that exists on a class object. It is a function that exists on a class object. It is a function that exists on a class object. What does that mean? What does that mean to y'all? BJ, what does that mean to you?
It's a function with the properties of a variable.
No, object, not variable, object. Object. What is an object? What does an object mean to any of y'all? John, what does object mean to you?
It contains the values, or those can also contain properties.
Yes, values or properties.
But as we see in this case, they also contain methods.
Do y'all know what this is? What I just put on the screen, the console?
Can you zoom in on that? What is it called? The brackets?
It's an object. And if I open this object up, do you see these? These are functions, right? The F stands for function. All of these functions are called methods. They are object methods. Why? Because they are functions that specifically exist on the object. So if I have an object, no matter what the object is, if I have an object that has a property, right? A property with the name of key, and its value is just an empty string. I can always call the object methods and say like object.keys and get the keys of this object. I really should have named it, but I'm just right over again. Object.keys, this function that exists on the object called object gave me back the keys, and the keys is named key. If I had a key with a different name, this key name is going to be name, and it's also going to be an empty string. It will give me back both of the keys, this one and that one, as strings, key and name.
Because you're calling both of them.
No, because I'm calling keys. I'm calling keys, and the job of keys is to give me the keys. It returns keys as an array of strings.
Okay.
Yeah. But the point is there are functions that exist on objects. Everything in JavaScript is an object. Do you understand that?
Mm-hmm.
What does that mean though? What does that literally mean? That means that numbers, every single number you see is actually this. This is what a number is stored as in JavaScript, as an object. And then this object has keys on it. One of the keys is to string. This key of to string points to a function that takes in the value that you pass and then returns that value as a string. So something like this. Return $. Something like this, where not value of value. So this is every single number has methods that exist on the object, and this method points to a function, and the function returns some value. So these are number methods. Number methods are literally just methods, or just functions, that exist on every single number object. Every single number object. So if any variable points to a number, that variable is going to have access to the functions that exist on the number object. Does that make sense?
Yes.
Does that make sense, John?
Yeah.
Does that make sense, BJ?
One more time. So you're saying if something is affecting a number and all the JavaScript, if all the JavaScript is ran by numbers,
Not numbers, objects, objects.
Let me finish. Because you said numbers.
No, I said objects. I said everything in JavaScript is an object.
Okay, trying to understand. My bad.
Everything in JavaScript is an object. The number class, any number is going to have access to the number class methods because number classes are just an object. All these numbers are really objects. They're stored as number objects. You understand? In JavaScript, it's stored like this. So when I write this, right? When I write 4 is not stored as a 4. In JavaScript, this is really an object. This is an object that says something like this. Class, number, like this is what it looks like under the hood. Value, 4, and then it also probably has like toString. And then that toString points to a function that does whatever it does. You understand? This is what we see. This is what's really in the background. So if I say num equals 4, this num variable is going to have access to everything that 4 gives us access to. If I call num.value of, what do I get? The value of num, the object. You understand what I'm saying here?
Super dope.
BJ, you understand?
BJ, you're taking Python classes, aren't you?
My bad. I was on mute for too long. My bad. I was trying to get out of it. Yes, I understand.
Okay, so you understand that these are actually number objects, even though we see the 4 or the 1 or whatever we're putting the number to, the number is not known to JavaScript as a 1. It's really an object. And in that object, they have like properties. And when we say methods, we're just talking about the functions that you can call. So like there might be a property called value that's literally the number 4, but if it's not a function, it's not a method. That makes sense? If it's not a function on the object, then it's not a method. Methods are only the functions that exist on the object. Does that make sense?
Yes.
All right, so if I ask y'all what is a method, y'all should all say,
There are actions that can be performed on objects.
perfect. They're actions, functions that can be performed on objects. John, what would you say?
Actions performed on.
Function. I'd prefer you say function, to be honest,
Okay.
because it's like I want y'all to connect what y'all are seeing, because these things are not separated from each other. JavaScript is built on these building blocks. So once we learn what a function is, learning that you can assign a function to an object and that makes it a method is super important for like knowing what is going on in JavaScript. All right, so BJ, what would you say a method is?
A method is an action performed on a function.
Again, I want y'all to say function performed on an object, not
Function performed on an object, because JavaScript is objects.
Yes.
Okay.
JavaScript, everything in JavaScript is an object. Even the objects are objects. The functions are objects. Everything is an object. Even when we don't see it, it's an object. So methods, we also had number methods. That's one of the things we went through. So these are the number methods. We had toFix, and there's other ones that we didn't really touch and play with. But y'all can, as always, experiment with it for yourself to make sure it cements in your mind. Then we played with assigning numbers to variables. This is to exemplify the types, how you can assign 74 as a string, and then you can attempt to add the number, and what you'll get out of this is 743, because adding different types, data types, causes it to behave differently. One thing we did to get past that was, and let me just do it in here so that way y'all can see it again. If I say string equals 74, oops, and then I say string plus equals 3, you'll get 743, and that's not what we want. We want it to be 77. So what do? We created we pass this thing through the number object, right? So we said number, we're gonna say num equals number, and then the value, which is string. So now we have 743. I kind of actually just want 74. I'm gonna make string 74 again. All right, and then this is me creating a new number object and passing the string to that new number object. And now we get num equals 74. This is a number object, right? So this is converting the data type. We just converted the data type to a number object from a string. Then when we do the num plus equal 3, we get 77, because these are two number objects being added together, and they understand how to operate together. All right, then the next start is number operators. All right, so BJ, this is your turn. Just tell me what each of these number operators are doing. I think that's the last thing we have here. All right, so we have line 119, BJ.
Add by 7, multiply 10 but plus 7, 9 times 8. Is that reciprocal? What that is?
Which one you at?
Well, no, it's at 21.
All right, so you said this is assignment, this is addition operator, this is multiplication operator, this is division.
That's not division.
What is this?
It looks like a what's that thing? Percentage sign. That's something different.
It's a percentage sign, but what does it do? Let's see.
Oh,
This is 63. I gave it 0. Why did I give it 0?
because there's no remainder to it.
Ah, that's the remainder. Oh, no, it gives us the remainder as a result.
Yeah, it gives you the remainder as a result.
Okay. Division operator. Well, that's good to know. I would think the division operator would give us the. No, that's not the division operator. We are missing.
Yeah, and maybe I'm squinting too hard, but okay.
That is good point out. This gives us the remainder. I don't know. I thought the documentation was up to date, but maybe I wrote the wrong things. I don't know where my thing went. But yeah, this is definitely the division operator. All right, so this is the remainder operator. Remainder.
Right.
Yep, that's the remainder operator. It's called a modulus operator. Returns the remainder of two numbers.
No.
All right, so next one, BJ.
I took that
123.
one. exponent, so would that be two squared?
What operator is this one?
Is that the exponent, so it'd be 2 squared?
Yeah, that's 2 squared.
Okay, so it'd be 4.
Yeah, you just need to tell me the operator, the name of the operator. You don't have to tell me what.
Exponent.
Yeah. And then this one is showing how it does PEMDAS. So 5 plus 10 times 3. Let's see what that looks like. Oops. Where is? Where'd it go? Oh, here we go. All right, so obviously 3 times 10 was done first and then plus 5. So it follows PEMDAS. Also, you can add variables to it. You did multiply, remainder of 9, and then times 1. And then the last one was using parentheses. So that way we can do PEMDAS completely. But y'all should know PEMDAS. So I don't even think we need to go past that. All right, so that shows majority of our number lessons. Also the immutable numbers versus mutable. The whole point of this was to show the operators here. So these are also operators. These operators, the assignment operator, you cannot use these assignment operators on immutable variables. And operators.
Hazel place.
Nelia, mute yourself.
Sorry.
You're fine. So yeah, do y'all understand why y'all cannot use assignment operators on mutable versus immutable variables? Why you can use it on the mutable and why you cannot use it on immutable variables. I'm gonna go to Arnelia first.
What was your question?
So these are assignment operators: the equal, plus equal, minus equal, times equal, divide equal, right?
Mhm.
So why can you use assignment operators on mutable variables, but you can't use them on immutable variables? So the first question is, do you know what an immutable variable is? And do you know what a mutable variable is?
Okay, I feel like mutable variable is positive numbers and immutable variables are negative numbers.
No,
Okay.
the word mutable should be your next Google to make your life easier.
What does that say? Oh gosh. Liable to change.
Yes,
So-
mutable means it can change.
Yeah, so
Oh, and immutable is
Unchanging.
okay, static. I can say static, which is kind of the same thing, right?
Yeah, there's many words to say the same thing.
aren't
No, just very.
Hold on, John. Hold on.
sorry.
So Arnelia, right? So the question again is, why can you use assignment operators on mutable variables, but not on immutable variables?
Very easy because mutable is changeable and immutable is static, so it's will never change. So you can never divide, minus, or subtract anything.
Correct. So assignment operators are going to assign the value and change the value that's working on. So the 0 plus equal is going to end up being 1. Mutable num is going to be changed to 1 now. But if it's an immutable num, if it cannot change, and you try to add and assign the new value that's been added by 1 to an immutable number, you're going to get an error. We can look at that real quick. How do I keep losing this? So if we say const immutable equals 1 or 2, whatever. And I call immutable, I get 2. Well, if I say immutable plus equals 1, error. Assignment to constant variable. I cannot assign a new value to something that is not supposed to change. Now, if I say mutable, and by not declaring that's constant, is going to assume that it's not mutable equals 1. Let's say mutable plus equals 1. We should get 2. As you see, mutable is now 2. All right. So that's our review of numbers. Now we can move forward, right? I'm going to comment this out. Hopefully in y'all notes, y'all write something like can't use or can't change or reassign value if immutable. Stuff like that to help you know what is going on in these things. Your notes should really be tailored to you and what you need. But yeah, whatever helps y'all figure it out. And this part was for data types. So do y'all remember the last part, the comparison operators? Comparison operators. All right, John, this is going to be you. You were not part of the class when we compared the difference, but do you know the difference between triple equal and double equal in JavaScript?
Triple equal, if I recall correctly, is more strict, and double equal is not as strict.
Strict by what standard? What is it comparing differently in the two? So what's the difference between true and 1 and true and 1 here, 74 and 74 and 74 here and 74 here?
For triple equal, trying to explain it, I know.
Well, I'm saying what's the difference between this and this? Not even like the triple equal. I'm saying what is the difference between true and 1? I'm going to copy these also, and we're going to look at what they evaluate out to.
Aren't they comparing to operands to return a Boolean value?
No, they're comparing data types, John. The difference between true and 1, true is a Boolean, 1 is a number. Right? So the triple equal is comparing the data types. You see?
Mm-hmm.
And then loose equal is only comparing the return value. So these both return to true because 1 in the binary language is also true, while zeros is always falsy.
Okay.
Another example is 74 as a string and 74 as a number, right? 1 is comparing strictly the values and the data type. And now it's going to say false because these are not the same data types. And then this one is going to be not comparing data types. It's just looking at the return values. And both of these return 74, so they're true. Makes sense? So the difference is triple equal, the strictness is based off a data type. It needs a strict data type to match.
Mm-hmm.
Make sense?
Yeah, that's a little bit more clear than from what I learned, but yeah.
That's good. That's good. BJ, that makes sense?
Yes.
The comparison of data types.
Yes.
Anelia, it makes sense?
Yeah, it makes sense.
What is it comparing? The triple equal?
Data types.
Correct. And the loose equal is just comparing
string,
No, the return values.
return value.
74 and 74. What are strings, Anelia?
What are strings?
Yes. What's a data type?
A data type is a string.
A string is a data type. A data type is not a string. A data type could be a string. It could be a number. It could be an object. It could be a function. Those are all data types. Is true not a data type too? A Boolean? Are Booleans not data types?
Yes, they are.
So data types are, it's in the name. It's very literal.
Data types are datas,
Types of data
types of datas.
is what the data is. So we have this data right here. It's a 1. This is a number. That's a number. That's the type of data it is. It's a number. A string is the type of data this is. This 74 as a string is just a string of a 74. I don't know how else to say that, but like Booleans are true or false. Like those are what all Booleans are going to evaluate out to, true or false. So all Booleans are data types that evaluate out to true or false.
So is that 1 equal sign or 2 or 3? I mean,
Which one are you talking about?
Booleans, are those 2 or 3? Equal signs.
The equal signs are the comparison operators.
Okay, yeah, but they equal. A Boolean can only be like a true or false. So usually those are like 1, 2, or 3 equal signs, right? There's
You're talking about what this operator evaluates out to?
yes.
Yes, it evaluates out to a Boolean. So the operator, this operator, these comparison operators are always going to return either true or false.
Right.
The comparison operator itself is not a Boolean, but it returns a Boolean.
Okay, that makes sense.
Yeah, the comparison operator is going to compare two values. And if you use the triple equal, it's going to look at the data type and say, what's your data type? You're a Boolean. What's your data type? You're a number. What's your data type? You're a string. What's your data type? You're also a number. You're a function. You're an object. You're an array. Those are your data types. And then it's going to say, all right, well, does your data type and your return value match? The loose equal does not compare data types. It just compares return value. So as long as your return value is the same as this return value, as long as they evaluate out to the same thing, it does not care what type of data this is. All right, understood? Everyone
Yes.
understood? All right. Since this is something we went over before, right? And there's something y'all should have memorized, right? Y'all should know this. If anytime we have questions and y'all make a mistake, write it down. Write it down. I don't know how many times I can repeat it. Write it down. Write it down. Write down which mistake you made. So that way, next time you're looking at it, you're like, oh, okay, loose operator. My loose operators, like if I did not remember what my loose operator was, I would type down loose operator does not compare data types, i.e., that's like examples, string, function, number, whatever makes sense to y'all to write. If y'all need to write function like this and then write out a function to make you remember what a function is, whatever makes sense. But yeah, these are things we got to start writing down so that way we are hitting all forms of learning. Vocally, we're hearing it, we're repeating it to ourselves. We are visually seeing it by writing it down. And we're also building muscle memory because we're utilizing it when we're typing it out as we go along with the work. So we got to trigger all our senses to get our senses to really commit this stuff to memory. the sooner we get to really commit this stuff to memory, the less time we take when it's reviewing the stuff, the more fast you can refer to it and you can say it and be correct. And then when you're correct on it, you get to build on your knowledge of it, because we're going to go to stuff and we're going to reference this stuff again. And then if you do not remember it, you're going to start messing up in little small places, and the little small places starts to really add up. It really starts to add up. So I'm begging you, write this down and commit it to memory. All right, now that we're done with this, we're going to go on to JavaScript objects. So JavaScript objects is where you really start to learn JavaScript, in my opinion. Since everything in JavaScript is an object, that it just makes sense that objects is the most important thing to learn JavaScript. So if you were in Rob's backend class, y'all saw him work on classes using Java. Java is an object-oriented language. Everything in Java is also built on objects. I believe I'm saying that correctly. But as far as I'm aware, Java is an object-oriented programming language. All right, so we're going to go through JavaScript objects. All right, so the first things first. Why is it scrolling so fast? JavaScript's core, most often used and most fundamental data type is the object data type. JavaScript has one complex data type. Everything else are simple data types. One complex data type, the object data type, and it has 5 simple data types: number, string, Boolean, undefined, and null. Note that these simple primitive data types are immutable. They cannot be changed. They're also called primitive data types because they are the most simple data types you'll have: numbers, string, Booleans, undefined, and null. And they generally exist in all coding languages you'll find. While objects are mutable, they can be changed. Objects can be changed. So what is an object? An object is an unordered list of primitive data types. It's an unordered list of primitive data types. So this is a data type built out of other data types. As you saw, we had the function in our object. We had a we had a string, we had numbers. So it's built up of other data types. And sometimes even reference data types that is stored as a series of name and value pairs. So I said key value pairs, but it's also references name value. So each item in the list is called a property. Functions are called methods. Very key important. Only the functions are methods. Every other item is a property, right? So what are the methods? Functions. What are the properties? Everything else. Literally everything else is just a property. So consider this simple object. Var my first object. You have first name and favorite author. All right, Arnelia, I think you were the last person I called on. Or was it John? I think it was John.
That was me.
Okay, so BJ, you're next. BJ, what is first name and favorite author? What type of what are they? Are they methods or are they properties?
Properties.
Correct. All right, so what do those properties point to? What primitive data type does that property point to? Here are the primitive data types, BJ. The primitive data types, the simple data types, also known as primitive, are number, string, Boolean, undefined, and null.
But it's not gonna be null or undefined, so I'm gonna say it's a string. Because it's gonna
Yes, they're both strings, and you should know that because quotation marks. All right. Now, Arnelia. They said that every single object is a list. Well, not every single object. An object is an unordered list of primitive data types and sometimes reference data types that is stored as a series of name value pairs. So I'm gonna tell you right now, this object is specifically of the reference data type where it's a series of name value pairs. Can you point to me the name and the value? So these are a series of name and value pairs. The comma separates the name value pairs. Can you tell me which one is the name and which one is the value for each of these pairs?
First name is the name, the value is Richard. For the second one, his favorite author is the name, and Conrad is the value.
All right, correct. Think of an object as a list that contains items, and each item, a property or a method in the list, is stored by a name value pair. So generally, you're going to see objects like this as name value pairs, also called key value pairs. So if I switch to key, please do not be like, whoa, it's name. Both works. The property names in the examples above are first name and favorite author, as Amelia said, and the values are Richard and Conrad. Property names can be a string or a number, but if the property name is a number, it has to be accessed with the bracket notation. More on bracket notation later. Here is an example of another object with numbers as the property name. So we have age group. The property name is 30, also known as key. We have a key of 30, we have a key of 100, and we have the values being 2 strings, children and very old. And to access this, they tried to do age group.30. This threw an error. As you have seen, we usually use dot notation to access our objects, whether they be properties or methods. But since this one is a number, they have to use bracket notation. So this is how you'll access the value of the property 30 to get value children. Instead of doing the dot notation and calling the key or the name, you instead have to do a bracket and get it that way. So let's try that, right? Let's make our own object. We're gonna say const my object equals, and we're gonna add a few things on this object. Let's start first with name. And then I'm gonna say my name is Sage. And then next, I'm gonna say age, 26. And then we're gonna say, actually, we'll leave it at that for now, right? So next things next, we want to console log out the information that we just put in there. Also we want to get the number. So we're gonna say, I don't know, I'm gonna say 0. And I'm gonna put first index as a string. All right, so we're gonna try and get the name and what happens at 0. So my object dot name, want to console log that, and then also my object dot 0 is not gonna work. Instead, we need the bracket notation. And then I can pass the number as a bracket under the bracket. And that will access the property 0. The dot notation will access the property name because this name is considered a string. But since this 0 is actually a number, even though it's trying to assume it's a string, you got to access it like that. All right, so let's try this. What we're going to do is call node. I'm actually not in the file. What is this coding course? All right, so I got Sage first when I called node, and then I ran my JavaScript file in this node, this little node server I spun up. So I don't know where your javascript.js file is, or also where you are in terms of where the javascript.js file is, but y'all should be able to do this, where y'all call node and summon that. If y'all cannot get that working and y'all cannot figure out where you are in your directory, I'm at my root. My project is under coding course, and I just call the javascript.js file there. If you cannot figure it out from here, you can just copy this, go inspect, go in the console, and you can also use JavaScript in your console, and then be like my object .name, and my object, and then try and access the key from the number, and you should get first. It is best to avoid using numbers as property names. That is not something we do. They turn their number into a string. As you see, it does not matter if you turn it into a string or not. All property names are assumed to be strings anyway. But these are the two ways you generally want to access your object properties or methods. And one more thing about this. Generally, the only reason you want to actually use bracket notation is when you have like my object. And then on this my object thing, I want to add a string that says something like first, or let me say last name. Right? So I know I can't do my object dot last dash name. That won't work because the hyphen will break the dot notation, and it'll assume that it's no longer the same line. So these are the times where you really want to use bracket notation, when you know that the way how you're naming the file, the way how you're naming the property or the method will break the dot notation. Numbers also break the dot notation, but we, again, don't really use numbers. We generally use strings. All right, so continuing on. Did everyone see the difference between accessing their object with a name versus a number? Arnelia, good on that?
Yeah.
John, you're good on that?
Yeah.
BJ, you're good on that?
Yes.
Okay, sounds good. All right, it is worth noting that even though we change, I think we're moving a little ahead, my bad. All right, so as a JavaScript developer, you will most often use the object data type, mostly for storing data and for creating your own custom methods and functions. So y'all have already seen us use objects to store our data types. We made one called form response, and we also use it to create mock data with a whole bunch of key and value pairs. What does that look like? Do I have it? I can't find it quickly, and also I don't want to waste too much time, but y'all should know what I'm talking about. The interfaces or the types, those are objects. Y'all see the key value pair. Y'all see the mock data key value pair. And if you don't remember, you can always just look at the files and you'll see them in the community movement builder stuff. Y'all should start recognizing, oh, whoa, that's an object. All right. So now on the next example, right? This scroll is crazy. One of the main differences, reference data types and primitive data types. One of the main difference between reference data type and primitive data types is reference data type values is stored as a reference. It is not stored directly on the variable as a value, as the primitive data types are. For example, the primitive data type string is stored as a value. Person, Kobe. So we stored Kobe into this variable. All right. Then they have var another person. Another person equals person. Another person equals the value of a person. Person equals Bryant. The value of person changed. So now when we console log another Bryant, another person, we get Kobe. Why? Because another person was set to Kobe, or was set to person when person equaled Kobe. So another person understood that it was referencing the value of this. Then we changed the value of person, and person is the only thing that was changed, not another person, because another person was assigned to the value that's represented at the time. So that's the difference between reference data type, a data type that's referring to another variable or complex data type, or just something being assigned directly to a primitive data type. It just simply is whatever value it's assigned to. It is worth noting that even though we change person of Bryant, the another person variable still retains the value that person had. Compare the primitive data saved as value demonstrated above with the save as reference for objects. All right, so compare the primitive data saved as value demonstrated above with the save as reference for object. So we're going to try and do the same thing for an object. So we have var person, person equals name Kobe. Another person is going to be equal to this object. And then we're changing person.name equal Bryant. So now what happens here? Console log another person.name is Bryant. It has been updated. Console log person.name is also Bryant. So these are two different ways these things work, right? Why is it different? In this example, we copy the person object to another person, but because the value in person was stored as a reference and not an actual value, when we changed the person.name property of Bryant, the another person reflected the change because it never stored an actual copy of its own value of the person's property. It only had a reference to it. All right, so this probably makes no sense to y'all. Unless I'm wrong. Does that make sense to y'all? Does this make sense? Why it works different? Arnelia?
No, it does not.
Were you paying attention?
Yes, I was.
Which part does not make sense? Do you understand what was happening here in this section?
Yes.
All right. So explain to me what's happening in this section.
On this section, they're calling Kobe Bryant.
Go line by line.
Okay. So we stored Kobe into person, and then we stored the value person into another person.
Not necessarily the value, but yes. Actually, yeah. So the value of person, we store it into another person.
Another person, yeah.
So this is a reference type. This is a reference. Actually, no. Let me make sure.
Laura, what are you? Sorry. You put a fish in my face. I'm sorry. Okay.
Oh man, that girl trying to get in trouble. All right. So as you said, this is storing the value of a primitive data type. So these are pointing, variables are references to another value, but at this point, it has already been stored. So once it's already been stored, the value is not being passed. So what happens here?
Then we put Brian into person, so then it change.
Yep, we updated the value. And then when we console log, what are we seeing?
We're gonna only see Brian.
Well,
We
what,
console another person, we see Kobe,
and why are we seeing Kobe instead of Brian?
because we're. Oh, that's a very good question.
What happened here? What did another person get assigned to?
Kobe. Oh, so then it's only known as Kobe.
Exactly. It only knows the value at the time it was stored. It cannot see the new value because it doesn't have a reference to the new value. It only has a reference to the value at the time.
Yeah.
Right.
Okay.
So now here we have person with that's being assigned to an object. So going line by line, explain to me what's happening.
Well, person, they put
An object.
Yeah, it's an object and it's a value that.
This is the key value pair or name value pair.
Yeah.
They'll say the name and the value. So it has a name of name, value of Kobe.
And then var, another person that is storing the object person, which is Kobe.
It's not Kobe.
It's name.
It's an object with the key of name and a value of Kobe. You got to say that yourself. That way you're comfortable saying it.
Is an object that is storing a value of the
key of name. Key of name.
And a value, Kobe.
There you go. Key of name, value of Kobe. Remember, these are key value pairs. This is the key. That's the value. All right. So what happens next? What is doing with this dot on person?
It is calling the key. So then, and it's also, so it's person dot key, which is the name of the value.
Do you remember what this is called? Dot notation?
The dot notation?
Yes. In this previous example here, did you make an object on the left side of the screen? Did you make your object in your file?
Yeah, I did.
So the two ways to access properties that we went through are called what again? There's this way, and then there's this way. What's the name of this way?
Dot notation.
Correct. What's the name of this way?
The bracket.
Yes, bracket notation. You got to say it.
Notation, sorry.
Bracket notation. Bracket notation.
Bracket notation.
There we go. As I said before, we are going to activate every single one of our senses. So that way we really concrete this stuff into memory. Verbal senses, visual senses, and our mechanical, physical senses of sensory touch. We're going to teach our body to remember what we are doing. So we are accessing the key of name and assigning it, right? We see the equal sign, so that's the assignment variable. So we have the object, we're using dot notation to access the key of name and assign it to what?
To assign it Brian.
The string of Bryant. We're assigning the string of Bryant to the key of name, correct?
Yes.
All right. So what happens when we console log it out?
We console log another person dot name is Bryant. And then we console log person dot name, it is Bryant.
So what happened here? It updated
Because-
both, right?
Yes, because we called the key and it just changed the key.
So the key is a reference, right? So this is what it's trying to show us the difference. When you have primitive data types and you just set them to a variable, even if you use the variable as a reference and assign that reference to another variable, that will only understand the value at the time it was assigned. But the difference with objects is that objects are all entirely referential. So this key of name was happening when we say person.name. What's really happening is something more like this. Get oh, this is fine. Number 0 dot get value. Something like this, value of, and then there's really something that's like a setter. Let me see. I do not know how to work the setter on this. But we're gonna look at it like this, right? So it has something defined setter. That's it might be private. So essentially it has a setter and it has a getter, right? There's defined setter and then there's defined getter. We can't really see what they are, but essentially there's this function that exists on all these numbers or all these objects that allows it to reassign, which is a set, and get the value that it was referenced to. So when you update an object, the object itself will be reassigning its value. And then when you want to get the object, it references its getter and gets the value that you want to get. Because of that, the value is never really stored. It's stored as references on the object. Does that make sense? Arnelia, does that make sense? John, hello?
Yeah.
BJ, make sense?
It does. I'm about to take a bathroom break, right? Quick, right?
No problem. Go ahead. Arnelia, that makes sense? So these are references and they're obtained and set by a setter function and a getter function. And that's why this thing is not really, when we call .name, we're not really getting the value. Instead, we're calling a reference that retrieves the value at the time of whatever the value is. Make sense, Anelia? I don't know if you're muted.
Sage.
Yeah.
Not sure if you peep chat, but I gotta leave for my shift, so.
Gotta dip in the next 5 minutes. All right, sounds good.
Yep, appreciate you, man.
The video will be up and you can finish what we went through.
All right, cool. Appreciate it.
No problem. All right, Arnelia, are you here? Or are you just muted? I'm just waiting for y'all to come back. More we got a lot more.
Sorry, Stella was starting to do something.
Yeah, I figured.
Yeah, starting to choke on herself. She need water.
But you're good with understanding the reference, right?
Yeah.
All right, cool. All right, so that's the cool thing about objects versus primitive data types. Objects are mutable, but also because objects are mutable, that makes them much more prone to human errors, like someone changing an object and then that value being changed and affecting other things with a new value. Let's see. I'm gonna give BJ like 1 more minute.
For what?
He's in the bathroom.
Okay.
And then we're gonna continue on. We're almost up to an hour. I'm gonna say 9:30 is when we're gonna end. That'll be a 3-hour class. That should be enough. Well, as always, we start class late anyway. So really more 7 to 9:30. All right, it's 8:42. We're gonna continue. BJ will catch up. All right, you ready, Arnelia? Ready?
Sure.
All right. Make sure you write down in your notes on objects, dot notation, and bracket notation. All right, so the next thing about objects. Object data properties have attributes. Each data property, object property that stored data, has not only the name value pair, but also 3 attributes. The 3 attributes are set to true by default. Configurable attribute specifies whether the property can be deleted or changed. Enumerable specifies whether the property can be returned in a for in loop. Writable specifies whether the property can be changed. Okay. I never knew this, but this is very advanced object. Know the specifications of an object. But that's good to know. Not necessary to know, but that's good to know. All right. Creating objects. There are 2 common ways to create objects. Object literals, the most common and indeed the easiest way to create object is with the object literal described here. That's using brackets. This is an empty object initialized using the object literal notation. Var my books. Let's just copy. I'm gonna just copy this. I'm gonna put it in the chat too. And I'm gonna say object literal notation. Create object with object literal notation. And the only reason why this name is as it is being literal about it being literal. And what I mean by that is that this is an object, and an object literal notation is literally creating an object. Like that is how they're creating the object, by literally just manually making the shape an object looks like with 2 empty brackets. That is object literal notation. Just like dot notation is a dot and a bracket notation is a bracket. This is a literal object. All right. Let me copy and paste this. All right, so that's one way to create an object. This is an object with 4 items, again, using object literal notation. We got mango, round, yellow, shape round, sweetness 8, and then they put some functions on it. So I'm going to copy this. I'm pasting in the chat too. So this one now is a little different because this one has a method on it. So now we can take this, and it's up to you if you want to copy this and put it in the console, or if you want to do it in your command line. But we're going to say mango dot how sweet am I? And we're going to invoke it so that way we call the function. And we're going to console log this. Console.log. Actually, it's kind of extra because how sweet am I calls console.log. So all we got to do is call that. And we're also going to call mango.sweetness. And since this is a property, we do not need to invoke it with parentheses. That is not correct. We just need to say dot sweetness. But since this is a method, which is a function, we have to call the function. And we call the function by using parentheses. This has no arguments. It takes no arguments. So we can just call it with no arguments. So when I do that, I get sage first from the before, I get 8 from the sweetness, and I get what the function runs, a console log of good. So it only works if I invoke the function. If I don't invoke the function, what do you think I'm going to get, Arnelia?
An error.
No, instead we just get the definition.
Oh, you'll get page first. My name.
Nah, this is from previous console log. This is this stuff.
Oh.
Yeah. Let me just this stuff out. This right here. Now we have. So what is really being console logged here in Mango, how sweet am I? Actually, nothing's being console logged because I'm not console logging anything. And this is just a function definition. So if I did console log mango, how sweet am I? Now it's going to get console logged. And what gets console logged is the function definition. So it literally records what this is. Does that make sense? It's just a function. So it's console logging that this thing is a function that points to this method. But if I invoke it, this console log is going to get hit, and this is going to record undefined, or should record undefined, because this is just returning a console log. So you see 8, good, and then it returns the return value of this function, and this function currently returns nothing because console log returns nothing. But if I return instead this dot sweetness, let's see what happens. Good, and then finally the return value is being returned. So how sweet am I? I'm an 8 in sweetness. So that makes sense, Anelia?
Yeah.
All right. So remember, we have to invoke functions. If we do not invoke functions, we're just going to get the definition of the function and not what the function actually returns. And we also got to make sure that our function actually returns something. If our function doesn't return anything, then we're just going to get undefined like we did here. All right. So again, these are object literals with properties and methods on them. Here's an empty object literal. And here's one with properties and methods. All right, the other way to make an object is the object constructor. So we saw the number constructor, and I did show y'all methods on the object constructor, but this is essentially the object constructor and how it's used. You can call new object the same way you can call new number. So the same way I can say new number, and it creates a number class, a number object that starts at 0. I can also do new object. And if I don't give it any values, it creates an empty object. So let's say I wanted to add values to it. There's multiple ways to do that. I can either add them later, I can add the properties later, or I can build it all when I make the new object. So I could do like something like new object and then pass in, I think you could pass in an object key and then string. So you can pass in an object. I don't know if you can pass in an array. Well, yeah, you can pass in an array and it'll treat the array as an object. Since anything can be an object, I think it might take anything, to be honest. So yeah, I made a new object with a 1 and it turned into a number object. It doesn't turn into just an object, an empty one. It literally turns into a number object. If I did it with an array, it turns it into an array object. So again, everything in here is an object. And you can use the object constructor like that, or you can use it like this, where you assign it to a variable, assign to a variable, and then from there, you start adding properties on them. Object.color equals red. And then if I just call object, I get an object with the key of color and the value of red. All right, so those are the two ways you can make it, with the object constructor or the literal object. I'm gonna say 1 object literal notation and 2 object constructor.
Those up there, the
All right, BJ, are you back?
Yes.
All right, so again, the two ways you can create objects are with the object literal notation, which is literally making an open, 2 open brackets, and then either putting the properties or methods in them, or with the object constructor. We saw the number constructor. Remember the number constructor? Oops. Saw the number constructor. You also have an object constructor. So you can create a new object with the object constructor and add properties to it like this. All right. While you can use some reserved words such as for as property names in your objects, it is wise to avoid this altogether. What does that mean? Avoid using commonly used names that already exist. So for example, number objects, we know they have toString, right? So if I ever made a new number object, I would never do num.toString. equals, I would avoid doing this because this is now overriding to string. So it no longer points to this function that gives us a string. Now, if I did num.toString, I get an error. Num.toString is not a function. So please, please, please avoid renaming the property keys that exist on the default object. When you're making your own custom properties on an object, be specific to what it is and try to avoid generic names that might already exist on the object, or you will overwrite the value, right? And we do not want to overwrite values unintentionally. All right.
Can I ask you a question? Is there a
Yeah.
quick way to check if that function, if that is already a function
Is there a quick way to check if it's a function?
already before you?
Oh, if the property or method is assigned,
Yeah.
you call it. So
Oh.
if I created I'm gonna reassign it again. So you literally just call it, right? To string already exists. Also, you can look at num, right? If I look at num, it tells me what exists on it. So if I break it down, this is on the console. This is something you can't do in VS Code, but you can do this on the console. You can see exactly all the properties that already exist on the object. So you would not want to overwrite any of these properties. Make sense?
Yeah. So are you saying that we could add properties onto it if you wanted to?
Yes, you can add properties. So I can add a new property on my num call, hi Arnelia. And that new property is going to return hey. Now, every time I call this property, it calls hey. And I can still call to string, and to string will still do what it needs to do. I never change that value. If I call num, now we have a number object. See how we had this number object with all the number properties, the number methods on it. Now we have our number object with a new custom property called Hey Arnelia, and it still has all of the methods that previously existed on the number object. But now it has a custom one too. So you can add properties. You can also overwrite old properties, but it's bad behavior to overwrite old properties because you need them and people will assume they exist on numbers. You know, people will assume the default exists on numbers, and they'll assume, you know, the default properties and methods exist on all objects. You should always assume that no one touched or no one overwrote the default stuff. All right. Objects can contain other data types. We already know that. They can even contain other objects. Practical patterns for creating objects. For simple objects that may only ever be used once in your application to store the data, 2 methods used above would suffice for creating objects. Imagine you have an application that displays fruits and detail about each fruit. All fruits in your application have these properties: color, shape, sweetness, cost, and a show name function. It would be quite tedious and counterproductive to type the following every time you want to create a new object. So this is ridiculous. Yes. If we every time we want to make a new fruit, we call color, sweetness, fruit name, native land, show name, native to, that'd be ridiculous because then we'd have to write the same code 10 times. I'm assuming this is going to lead us to classes, class objects. So if you have 10 fruits, you'll have to add the same code 10 times, right? That makes sense. You have to rename each single fruits, pineapple fruit, banana fruit, and then rename the values every single time, right? What if you had to make a change to the native2 function? You have to make the change in 10 different places because each of them have their own native2 function. Now extrapolate this to adding objects for members on a website, and suddenly you realize the manner in which we have created objects so far is not ideal. That will have instances, particularly when developing large applications. So essentially, it doesn't make sense for us to use this very literal way of making an object. To solve repetitive problems, what do we need to do? We need to make this abstract and reusable. So to solve repetitive problems, software engineers have embedded patterns, solutions for repetitive and common tasks to make developing applications more efficient and streamlined. Here are 2 common patterns for creating objects. If you have done the Learn JavaScript Properly course, you would have seen the lessons in the Code Academy use this first pattern frequently. So they turn a constructor pattern for creating objects. So this constructor is a function called fruit. It has some properties, the color, sweetness, the fruit name, native to land. So Arnelia, you work with React components, and BJ, you also seen React components a little bit. This should look familiar to y'all because essentially this is our React component. This is how React components were made. They were made on these type of building blocks, where every single component is a function that sets the properties of the object to the properties passed in as argument names. So now color will always be set to the color. Sweetness will always be set to the sweetness. Fruit name will always be set to the fruit name. Native to land will always be set to native to land. And then this dot show name, it will always be a function called that console logs. This is this dot fruit name. And then this dot native to will equal a function that calls this dot native to land. That's the argument passed in here. And this dot native to land, then call for each on it. This is an array method. And on that array method, each country is going to console log grown in each country. All right, I know that's a lot, but we're gonna work on this, right? With this pattern in place, it's very easy to create all sorts of fruit. So instead of saying mango fruit equals all of that, Sorry, hold on. All right, so instead of saying mango fruit equals all of this, all we have to do is say mango fruit equals a new fruit, right? A new fruit, this new class of fruit, and then pass in the properties that are going to be assigned to color, sweetness, fruit name, and native to land. So they assign yellow to color, 8 to sweetness, mango to the name, and then the native to land, they give an array of South America, Central America, and West Africa. Then they can just call mango fruit, show name, native to, all that good stuff. All right, so let's try this, right? So what are we gonna do first? First things first, what are we doing, Arnelia?
We have to create a new function.
All right, correct. We're creating a new function. The function is going to follow the same pattern we do for React components, because this function is a class, right? It's a class object. So the same way we have number with a capital letter number, same way we have object, we have array, we have string, all these class objects. We're creating our own class object called fruit. So if I call fruit here, fruit is not defined. So we're going to define fruit. So function I'm gonna say creating a class object. We're gonna have function, fruit. And now it takes a few parameters, and these parameters will act as the properties on our objects, on this new object we're making. So we want color, we want sweetness, we want shape. Actually, we want fruit name. I'm gonna just say name. What else we need? And then we want where it's native to. The native to land. I'm gonna say land's native to. And then we're gonna return. What are we returning? BJ, what are we returning?
The object we're creating.
Exactly, the object we're creating, but we are binding the properties to this. So y'all have never seen this before. This, when used inside of an object, is referring to its parent or its name. Not its parent, its name. So this is essentially fruit. This is referring to the self. Does that make sense? So every single fruit object is going to have a property on it that's now being assigned the value of the color. So we are creating properties on the object fruit. So these two things are substitutable to each other. And we are creating a property on that object fruit called color, and we are assigning it to the color. So it's the same thing as saying fruit.color equals the color. But since fruit is not defined, this knows to define itself by itself, you know? Does that make sense?
Made sense until you said this, know how to find this into itself.
This, yeah, this knows that's referring to itself, the fruit.
So like, you mean like I could call orange and it'll say the color, sweetness level, name, and it's land native to?
What do you mean you can call? Wait, repeat their question one more time.
Do I actually have to say fruit, or would I have to, can I say like orange, apple? And then
All
like
right, so what we're doing here, the same way how we created the same way how we created var mango equals new object, and we said mango, we use the dot notation and assign yellow to the value of color, to the property of color, right? Mango doesn't exist right now, right? In this function, we don't have something called fruit. We never said var fruit equals new fruit, right?
Mhm.
We didn't define that. So we cannot say fruit.color yet.
Okay.
But using this, we can say, hey, fruit, everything that assigns, everything that calls you new object, we want to assign your variable, your property, not your variable, your property of color, the same way how there's mango.color. We want any fruit.color to equal whatever has been passed in as color. So that way, when I call new fruit, when I say new fruit and I pass a color to it, I'm gonna say banana. So when I make this new fruit, right, and I say console.log banana.color, what do you think the color is going to be? Arnelia.
I'm thinking, not gonna be anything. So it's gonna be
All right.
color.
It's not going to be color. Color is a, what do you remember function? Do you remember how functions work?
Yes.
How do functions work?
They call on,
What is the anatomy of a function? Can you break down the anatomy of a function? Do you remember when we went through the anatomy of functions?
yeah, key values. Well,
That-
that,
That's not the anatomy of a function. That should be up here. All right. Let's look at the anatomy of a function again. We have the declarations right here, right? The declaration. I am declaring a function, right? Then we have the name of the function. The name of the function is create alert. Then we have the argument being passed to the function. The argument or the parameter is custom text. Argument, parameter. Then after we have our argument, we can assign a default variable to it. We're not going to assign the default variable, but you can assign a default variable. Then the next part of it is the scope. We define the scope by the curly braces. Then inside of the scope, you have access to your arguments / parameters. So inside of my function scope, I can call the argument again and manipulate the argument. Understand?
yes.
So we are doing the same thing in here. I gotta delete this. We are doing the same thing in here. This is the declaration. This is the name of the function. These are the arguments. Inside this argument, what are we doing? We are assigning to the object, every single fruit object will have a property called color. And the property of color will equal whatever we passed in as the parameter. So in here, we passed in yellow as a parameter. Yellow is the first parameter, so that's going to get passed in as color. And the same way how we did mango.color equals yellow, this refers to the self. This refers to the object it is in. Since this is in the fruit object, you can essentially treat this as if I wrote fruit.color. You understand?
Yes.
So the reason why they named it this color is because they didn't want people to confuse what color was being referred to. The color here is the property on the fruit object. This is the argument being passed to the function. Make sense? So let's see
Yeah.
what happens. Let's see what happens. Let's see what happens when I do fruit.color. See if that works. Pretty sure it won't work. Let me also delete this. All right, so you see this gives an error. This should give me an error. Well, it's undefined. So not an error, but it's undefined. But if I do this instead, I get yellow. Why does that work? I cannot be inside of fruit while fruit is being defined and also say fruit. Fruit has not been defined yet. But I can refer to it as it's being defined and say, hey, while I'm inside fruit, this refers to fruit. Does that make sense?
Yeah, it does.
All right, BJ, does this make sense now? This referring to the object that it is in.
Yes.
All right, cool. All right, so now we're gonna assign all the properties to fruit that we want to be assigned every single time fruit gets called. That way we do not have to make a literal object for every single fruit object we want. Instead, we can abstract away the properties that fruit needs, and anytime we need to call a fruit object, it will have the properties built in. This is how they built the number object. This is how they built the array object. This is how all objects in JavaScript are built. They're built with a default class, and those classes have built-in properties. And every time you call a new object, you get the built-in properties. So our built-in properties are going to be color, sweetness, which points to sweetness, name, that points to the name, and then what do they have here? This dot native 2. This dot native 2 is going to equal, we're going to use an arrow function because we are fancy and don't need to write the old functions. This dot native 2 is going to be a function that returns this dot lands as native 2, and then for each we gotta assign that. All right, so we gotta also assign this dot lands native 2 to equal this value. So the reason why we gotta set these as properties and we can't just use them as the values passed in is because of the referential versus primitive data type thing we saw. This is gonna point to a reference. This is a reference. So whenever this is changed, whenever lands.native2 is changed, that's gonna update. Versus otherwise, if we just pass lands native2, it will only be what lands native2 is at the time that it was passed in. And that will not keep track with its values. So this dot native2 should return lands native2, and then for each of them, for each, we want to call console.log on the value native land. And then console log native land. All right, so let's see. I should be able to call banana new fruit. Sweetness is going to be a number. Bananas are not sweet. I'm gonna give them a 1. Lucky I don't give it a 0. The name is going to be banana. And then the land native to West Indies, Africa. I'm not going to go any further. And then we're going to console log out banana color, banana.sweetness. And then also let's make another one called const apple equal new fruit. And we're going to make this a red apple. Sweetness is super sweet, 8 out of 10. I'm going to say cherry apple. Is that one of the apples? And then, is that what now?
The gala apples out. I don't know, cherry. I didn't
Gala?
have a cherry. Gala, Gala.
Gala.
Do Honeycrisp.
Honeycrisp apple is actually really good.
We'll pretend they're in America and Latin America. All right.
I actually like Gala's better because they got more of a crunch than Honeycrisp.
Oh, it's called Gala.
Yeah.
All right, so we're also gonna log out the name of Apple, apple.name, and apple.sweetness. And then last but not least, we're gonna say banana.native2. We're gonna fuck around with the methods, apple.native2. And that's gonna prove that we are able to create class objects with properties and methods on them. All right. Let's see what I get. Let's see if I get any errors. All right, yellow 1. Then we got the gala apple, sweetness of 8. I could say banana color. Banana name. All right, yellow banana, not sweet. Gala apple, very sweet. West Indies, Africa, America, Latin America. Cool. That's why it looks like that. That's one whole. All right, cool. All right, so that makes sense now. Y'all starting to see oh my god. Number. So y'all kind of see how JavaScript is built in all objects, right? And how you also have the ability of creating new objects using class objects, and how everything under classes allows you to quickly make these objects with default properties and default methods that you can always call on. Yeah?
Yes.
Yes.
All right. So hopefully y'all starting to like put things together and like, wow, okay. These are all the same things. JavaScript is literally just the same thing over and over again, built for different reasons, built for different things, built to one object for fruits, one object for numbers, one object for strings, one object for functions. All these things are just objects, all slapped up on top of each other until they build out complex applications. All right, so with this pattern in place, it's very easy to create all sort of fruits. Make mango fruit, pineapple fruit, Oh, I didn't even copy and paste this correctly. All right, I'm gonna copy this and put this in the chat. So that way y'all can make sure that y'all wrote down the right thing. But yeah, understanding class objects, they operate similar to functions, just the same way as functions do, because we're using a function to return an object. What is next? If you had to change the fruit name function, you only had to do it in one location. They're showing you if you want to manipulate one of them, right? Pineapple fruit, show name, this is a pineapple. And if I want to change the fruit name function, where's the fruit name function? I think it's talking about the property, because what are they talking about? Fruit name function. But anyway, if you want to change any of these, if I wanted to change bananas native2 function, all I have to do is overwrite banana.native2. No idea why I'd want to do this, but just to show you the example, now banana.native2 has its own function, and banana.native2. This allows us to be more specific about what each thing is doing, right? So we abstracted away the logic of what fruit does. Now fruit can handle any type of fruit. Now, if I want to be more specific for banana and its native2 function, I can be more specific and give it its own native2 function. And then every other fruit can have the same native2 function. But this is exactly how I believe it's called inheritance. I want to call it inheritance. But yeah, essentially, the key here is separation of responsibilities. All fruits know they're fruits because they have these default properties. All banana objects or all bananas instances of the fruit object will know they are bananas because they will have these specific things and they'll do whatever banana related things they need to do. I don't really think we got to go through all of this stuff. Also, we only have 4 minutes. So in the last 4 minutes, let's look at this part. Prototype pattern for creating objects. So you have function fruit, right? And then fruit.prototype.color. So this is the same thing as doing the this dot. This dot color, instead of doing this dot color, you can say every fruit, the prototype for the fruit object should have a property of color, and that should be yellow. The prototype of the fruit class object should have a property of sweetness. The prototype, So essentially, they create a prototype of the fruit object. And the prototype defines how all future fruit objects will be built, like any prototype does. It is the blueprint. So essentially, you define your blueprint and you set the values on that blueprint. And that way, you can also create new fruits. And this is how we call the fruit constructor in this prototype pattern. So if you use the prototype pattern, all you have to do is var mango fruit equals new fruit. And you don't even have to assign the values because you already assigned them to these default values. So now anytime you call mango fruit, it'll be called with these default values. And if you want to specify what the values are, then you have to pass it into this as arguments. So I'm just going to copy this for the sake of time. I will say the preference, or at least my preference, is using this over using prototype. But I would imagine if you're writing like scripting language or like you're trying to create packages or something, like there might be use cases where you want to use prototypes as a more consistent pattern. To prototype. All right. All right, cool. This dot show name. Let me call it again. Cannot read property of undefined reading for each. Oh yeah, I did. I fucked this up. I'm just gonna take this out because I don't know what I'm doing there. What is it saying? Apple.native2 is not a function. Well, that's tweaking. Why is it tweaking? Apple.native2 is not a function. This was just working. New fruit. Oh, it's because I'm overriding what fruit is, I think. Maybe. I'm like, I didn't really make many changes. Okay, yeah. We're defining fruit twice, so now it's bugging out. Let me comment this stuff out. So y'all should all have the constructor pattern. I wouldn't say down pat, but y'all should all have it for reference. And then if I do this, generic fruit. These are the default values. Actually, no, this is not the default. It should be overriding. This is a pineapple. Weird. New fruit. And we are assigning the values. But anyway, I don't want to hold up your time. It's 9:32. The prototype is not the preferred way for obvious reasons. Look at it not working exactly as it's supposed to. I just copied and pasted. They even typed this myself. The preferred way is obviously the constructor pattern. And yeah, this is working with objects. The key to working with objects, though, is really understanding dot notation, bracket notation. If there's anything y'all choose to focus on, understanding how to navigate through an object and creating your own objects to object literal notation and the object constructor. And then the last part is learning the object methods that currently exist on objects. Object methods in JavaScript. Go to your Mozilla Web Docs. As you can see, object.prototype, all the stuff it already has. And then these are the important ones. Object.assign. Object.assign method copies all enumerable properties from one or more source objects to a target. So source, target, object.assign from the target, from the source to the target. So take B, C, and assign that to the target. So when we console log target, it now has A, B, and C. And you see B was overwritten by sources B. So object.assign will take the values from source and overwrite whatever values target has. And anything that has not been assigned, it will give it a new value. So C5 was not already assigned, so it gives us a new one of C of 5. So it is important for y'all to know the built-in object methods that you need to use constantly. Those are going to look like object.keys, object.values, object.values, which gets you all the values on an object. Object.keys gets you all the keys on an object. Those are some of the most common ones. Object.entries is pretty common too. This turns into an array of key value pairs, I believe. Returns an array of its own enumerable string key properties. So yeah, key value pairs and arrays. So these are very useful ways to get values, to manipulate these and use them as you need to. which is generally turning it into an array because arrays have very useful object methods. But yeah, I'm gonna drop this link also in the video. All right.